So today I will be telling you how to perform few tasks on Atmel Studio. So let me open our first task, which was to store 13 in register, 16 in binary and display it on any port, and then at 25 in it. Okay, we have to show its simulation on Atmel Studio using these commands. So let me open my Atmel. It may take some time. So now, as you can see over here, this is the code of task one, which is what to store 30 in the register, 16, and then add 25 in it in the binary. So as you can see over here, I have used the load directory command LDI, which is used to load a value in the register. So it will actually stores the 30 in the register 16. This is the binary value of the 30. Okay, and now this is for initializing the register 17, in which we will just store 25 because we have to add 25 in the register 16. So that's why we have to store first 25 in some other register. So now I am declaring the output B as an output port where I will be displaying the results of my register 16. So now I am adding the two register 16 whose value inside it is 30, and register 17 in which the 25 is stored. Now this command will add both of the register. Now 30 plus 25 is equal to 55, that will be stored in the register 60 now. And when I did the output on port C, so it will display that the in register 16 there is now 55 instead of 30. Now then I'm clearing the register 16. So let me debug it and show you how it works. Start debugging, and now it's debugging. Let's open the windows of the input output, so where you can see on port B and port C the results. Now I will just press this command, which will press this and it will execute command one by one. So first of all, it initializes the register 16 and it will store the value 30 in it. As you can see, the hexa of the 30 is this. Now after next time in the register 17, the 25 is stored. As you can see, in register 17, 25 is being stored. Now what will happen on the output port B over here, the value of the register 16 will be displayed. As you can see over here, the value is being displaying. Now the addition will happen. Now the 25 will be added in the register 16. Now that output will be declared on the port C over here. As you can see, as I press the next command, executed, and now as you can see on the register 16, first it was 0x3e, which means the 30 was stored in it. Now it's 0x37, which is the hexa of the 55 hexadecimal system. In values are being stored in hexadecimal system. And now after, when I will execute this command by pressing this, the register 16 will be cleared. As you can see, the register 16 is cleared, it became 00. So that was our lab task 1. So now I will move towards our lab task 2, which is to take input from one port and display it on the another port. So let me show you the Atmel simulation of it first. As you can see, this is my task 2, and here is the code. LDI is used to initialize the value inside the register. Out is used to show the result on any port that we want to declare as an output, and in is used to basically put the value inside the register from any pin. Okay, it will be reading data from that pin and will be storing its value to the register 20. Okay, now subtraction function is used to subtract it, and output is used to display an output. So I will just start debugging it. Stop debugging. Now for that I have to open my laptop 2 instead of laptop 1. I have to close it first. Now the task 2 is opening. Now as you can see the task 2 is open over here. So now I will explain you the code of the laptop 2 already. So now I will just debug it, and I will just open the window got open. Now I have to select a port B and port C because over there I'm just displaying my output. So I will just select port C and port B. Now again I will execute the lines of the program one by one by clicking this step into. As you can see in register 20, the value or hexa value of the is stored, which I have assigned to the register 20. And now after in R21 the next value will be 0x17, which is the 25 value in the decimal system. So now after that you will see the output on the DDRB, as you can see over there, and now you will see the output on the DDRC. And now the input it will be taken from the pin C, okay, the register from the register 20, and now it will be subtracting both register and displaying the output on the port B R20. As you can see over here on port B it has displayed the output, and this was the R20 input which was being taken from the port C. Similarly, now the code has finished. Now I will just open the laptop 3 and we'll show you the simulation of Atmel Studio first, and then we will move towards the Proteus. Display the charging sequence of the using these commands. As you can see, these are the commands we should use: clear, CBI, SBI, skip bit, or clear bit if carry is not equal to 0 or 0, and initialization. So I will just open my lab 3 task. Task 3, I will just open its main file because it will be opened over here. Now I will just copy it first, cross it and paste it over here. Now let me explain you the code. Over here we are just initializing the value to the register 16 and register 18. As you can see in the comments, storing the value 00 and 00, it is FF in the R18. Now out DDRB, now I'm declaring port D as an output port, okay, and now I am setting a bit 1 on the pin 0 of the port D, okay. Now after that what's gonna happen is that LDI R19, 0x25 is being stored in the register 19, and after that I have made a loop over here, LOP1, which will keep on repeating again and again until the value of the register 19 becomes 0, and it will be displaying the output on the port 16, the value of the R6 register 16, and will be adding register 16 and 18. And after that over here it will check that if or 0 on the status register, if or 0 is 1, then it will exit, otherwise it will keep on repeating again and again and keep on jumping over here loop 1, and this whole loop will be keep on repeating until the value of the R19 becomes 0. So let's debug it. So as you can see in R16 and R18. In R16 00 is being stored, and in R18 0xFF is being stored. Now the port D will be declared as an output port. Let me show you over here. As you can see, the DDRD has been declared, the whole port has been declared as an output. Now the next command is, now we have initializing the value to the register 19. Over here you can see that the 25, I mean the 37 in decimal system is being stored in the register 19, or 0x25 in hexadecimal system. Now we have entered in the loop. Over there we are just decrementing the value of the register 19. Now as you will see, it will execute the take command, the value of the register 19 will decrease. As you can see over here, it was first 0x25, now it's 0x24. Now after that it will declare the output of the value of the register 16 on the port D, as you can see over here, which means our first LED will be on over here. Now it will add the value of the register 18 in the register 16 and save that value in the register 16. After that it will check if our status register of the 0 in the status register is 1 or 0. If it's 1, then our loop, it will jump back towards to the loop 1. If it gets 0, then the program will exit. Now I will show you that. Now as you can see, I am executing this, the LEDs are getting on and off, on and off, and as I keep on repeating it, it keeps on jumping on the register 9 from to the loop 1 and keep on executing these 4 commands, and the value of the register 19 keep on decreasing as much as I repeat it. As you can see, now the value of the register 19 is 01E. Now it will keep on changing until it gets 0. So over here I will just stop debugging, and now let's move towards our task 4. Now the task 4 is to take two values from the two different ports, and we will compare them and show it on the third port if they are equal or not. If they will be equal, then this value will be displayed on the port, otherwise this value will be displayed on the port. So let me show you the Proteus simulations first. So the two Atmel simulation, I mean task 4, I will just open the main and I will just copy this whole code that I have written, and I will paste it over here, and now I will start debugging. So and I will explain you the code. So now over here, as you can see, I am initializing the 3 register and storing values in them. Okay, and now I'm declaring the 3 ports as an output port. So let me select all the 3 ports from this input output window. Now in the next 2 lines, I am just reading the contents from the port B and the port C of the register, the values of the register 19 and the 20, and then now I'm comparing the register 19 and 20, because we have been told that if the value that is being compared on the register is this, then display a specific value on that port. If it's not equal, then display the other value on the specific port. So brneq then is equal to jump to the next command if our 0 register is 0, then it will jump into this loop and will keep on executing this command. Okay, if our values, compared values, will be same, but if they will not be same, then it will jump towards this line and keep on repeating it. So let me show you how it works. So as you can see, I have simulate the first 3 lines, and the register 19, 20 and 21, the value is being stored on the ham that I have initialized in the program, and now the output is being declared on the ports, as you can see over here. Now the input is being read from the 2 ports. As you can see, now the value is being compared, which is being compared internally. Now the values that I have stored in the register and 19 is same. As you can see, it's 0 0, so it will just jump towards the done. If it was not same, then it would have jumped towards the no loop and will would have keep on repeating these two commands. Now it will just repeat these two commands, and now I will just stop debugging over here, and I will move towards our activity 5. Now our activity 5 is the implement following commands and just comments about their function. So let me open my lab task 5. Over there I will just show you these commands and their function. I have already commented it, so it will be easy for you all to read it. So as you can see, this is our task 5. Now LDI command is used to initialize the value in the register 16. Okay, any specific value that user want to store in them. Now out is used to declare the ports as an output. Okay, now over here we are just declaring DDRB port as an port B as an output port, and the pin B port as an output port too. Sorry about that. Now subtract command is actually used to subtract two registers. The values which is being stored or which is stored in those two registers, that will be subtracted, and the value and the result will be stored in the register that is written first near to the sub command. Now inc is used to increment in the value of the register 18, and the dec is used to decrement the value of register 16, 18. And now mov command is actually used to copying the contents of the register 18 into the register 16. What it will do actually, it will copy the value of the register 18 and it will store in the register 16. Now sts command is used to store data, and now I'm storing this value in the register 18. And com command is actually the complement, which will complement the value of the register 18. And this is just the jump. Here is used to jump the execution line to the loop where we have declared this. Jump here means that this will jump over here, as I have written it over here, so it will jump here. So let me just cut it and write it over here. So now when I will execute it, when it will execute this line, and it will jump over here instead of ending the program. So now let's copy it and paste it over here, and let's cross it, and now let's just debug. Now as you can see, it's debugging, and as I executes the lines one by one, or the commands that I have written on the lines, you can see the output now, and you can see the values of the R16, R17 and R18 over here on the registers window, where all the registers are being used that we can use. Their range is from 0 to 31, so total 32 register can be used to store data. And now I'm subtracting R17 and 18, and now first you see that the value of the R17 was 0xff, and the value of the R18 was 0x19. So when I subtracted them, the value was stored into the R17. So the value of the R17 will not be now 0xff, it will be 0xex. Okay, now I am incrementing the register 18, so the value is increased in the register 18. As you can see, it becomes 01, and now I'm decrementing the value of the register 18, so it will be decremented. As you can see, it became 0x19. Now I'm just comparing the values of now I'm just copying the value of the register 18 and storing in register 16. Now you will see that the value of the register 16 is as same as the register 18, because I just copied the value of the register 18 and stored it into the R16. That's what move command do. And sts is used to store the value in the register 18. Now the value of the register 18 will be changed. As you can see that the value of the register 18 is being changed. Now I will just complement the value of the register 18 over here. You can see it became 0xex. Now jump here is you will jump this line over here, and then it will again run this program. As you can see, when I press to execute the next line, it just jumped over here, because jump command is used to jump or program pointer from one line to a specific line that we want to execute first. Com is used for the complement. sts is used to store data in the register. mov command is used for copying the value of one register into another register. DEC is used for the decrement, INC is used for the increment the value of the register, subtraction sub command is used for the subtraction of the two register, and you already know the LDI and out command, why are they used. So let me cross it first. I want to stop debugging, and sorry about that. Now I will just open the Proteus. Now there is a little bit problem with my Proteus. I don't know what's wrong with it, but whenever I upload a code and simulate it, it just get crack, or you can say it just break. Like the Proteus simulation fails, even my code is all right. I don't know what's wrong with it. I tried to search that error, but I couldn't find a solution. So let me show you. But some simulation is working. So over here we will just go to microlab, lab simulation labs to Atmel codes. Now I want to simulate the task 2 first, so I will just upload the hex file of the task 2. And now as you can see, I try to simulate it, simulate for a little. Oh, it's simulating actually. So now you can see, as our activity 2 was uh, to use these commands, okay, and to take input from one port and to display it on another port. Okay, now over here as you can see that I'm taking an input from the port B, okay, and I'm displaying it on the DDR or on the port 4D, okay. So that's why it's just 00. Now I will just stop simulating this task, and I will show you the lab task 3, which was to turn on the LEDs. So I will just upload the hex file of that task. Okay, now as you can see, it's already uploaded. Now the LEDs are on in the sequence. Now I don't know why my LEDs are not turning off, since this is getting red, so it means the LEDs should get off. I know the reason why they are not get turning off. Actually, I haven't given any time delay, so the LEDs are just getting off for a very short interval of time, like for just few millisecond, or you can say 1 millisecond. It's such that we cannot just see it, but the LEDs are being closed. As you can see over here, this red line means that they are getting high, blue means that they are getting off. So I will just stop the simulations. I will cross it. Now I will show you the task for simulation. I hope it will work too, because last time it wasn't working. So let's just, it was the comparing activity, okay. So let's just try to, okay, let's open the lab task 4 again. And let's upload our hex file in it. Now I will just simulate it. Now you can see that this simulation is not working. It will just give some opcode error, and I don't know how to resolve it. I did search on internet, sir, but there was no solution on it. So I guess that there is some bug in my Proteus, due to which this simulation is not working. But I did write the code, and it was tried. As you have saw the simulation on the Atmel Studio, it is working on the Atmel Studio, but it's not working on the Proteus due to some bug in my Proteus, because it's an 8.10 version of the Proteus and it's not too much stable. So now what, I will just start the recording of our lab 3. Okay, there were few tasks of the lab 3. I will just close this segment. So now let's move towards the activity 1 of the handout 1 of the lab 3. This is the Proteus, okay, and let me open the code to lab 3 Atmel code of the task 1. Yeah. So this is the task 1 of the lab 3. Now I will just open the tasks of the lab 3, which was the actually, let's refresh it first. Let's turn on the Wi-Fi. So our first activity was to write a code and take input from port B and to check if the number is odd or not. If it's odd, then blink the LED on the port C, or if it's even, then they should the LEDs should turn on in a sequence. So let me upload the hex file. Okay, so in F fifth semester. Simulation task 1, not ELF file, hex file. Okay, now let me explain you the code first. So in this code, actually we are just writing the code and controlling our microcontroller by using the C language. Actually the include, these are the libraries that we are including. This is the area library and this is the delay library, because I am using delay in this program. So first I'm just declaring the 3 ports of my AVR or microcontroller as an output port. After that I have made an array of the char and I'm storing values in it. Okay, and then after that I'm displaying those values on the 7 segment display, and in the for loop it will just keep on reading these values and will display it on the 7 segment, and that port output is being taken from the port D and B, and the value of the array, like if over here the first, it will be the 0 on the 0 index of the array, the value is 0x3f, which is the hexa value of the 1. Now the 1 will display after the delay of the 1000 millisecond, or you can say 1 millisecond, the next value will be displayed, and so on. So let's open the first task, and this is the code of the first task. Actually I think I have explained you the wrong code, so let me explain you this one. That was the code of the 7 segment of the handout to task 1, I guess. So similarly over here I'm just including the libraries first, and after that in the main body of the loop I have just write a while loop which will keep on running this program forever. Now I'm declaring port B as an input port and port C as an output port, because we have to take input from port B and we have to display the values through the port C. Now after that I have just created a variable of the char type Z, and I have assigned the value of the Z, the value of whatever comes on the pin B, it will be assigned to the Z. Now I'm just checking that if whether my number is even or not. For that I have just taken its modulus with the 2 and have checked if it's equal to 0 or not. If it's equal to 0, then it will display the value 0b even over there, otherwise it will display the odd value. Okay, after that there is a delay of few seconds, and then it will keep on running again. But if our value is not even or odd, then it will just, if our value is even, then it will just run this part of the program, and then on the port C it's 0x00, and that's our program. Now I will just run the simulation of the Proteus so you will have an idea. So as you can see that the value is actually even, so the alternate LEDs are being on. So if the, I will change the value to the odd, now you can see the LEDs are turning on from LSB to the MSP. Okay, so this is was the task one of the lab handout one. Now moving towards the task two, this code is actually what I have explained you already over here. So you can see it. Write a code to monitor bit 5 of the port C and to check if it's high or low. So I will just open the Proteus of that file first. Activity 2. Now let's move towards our code. Okay, so this was the code of the lab 3 handout 1 task 2, which I have explained you. And I guess I didn't explain you the code of the task 1, so I will just open it and I will just explain you that. So this is the code. Okay, now over here as you can see that our, what we are doing is basically just including a library. Okay, and after that in the main body of the loop we are just displaying, declaring two ports as an input and output port respectively. Now we are comparing that if the value of on the pin C is equal to 00100, to check that fifth bit of the port C is high 0 or not. If it's high, then it will display 0x55 on the port B, otherwise it will display 0xAA on the port B as written in the manual in hexadecimal AA, or 55 if the port C is high or not, the fifth bit of the port C. So we will just simulate it on the Proteus. So now as you can see it's not high, so it's displaying 0xAA on the LEDs. Now if I will change it towards the high, it will turn on the alternative LEDs, because on binary the value of the 0x55 is 1010101. Okay, and the 0xAA is 0101010. Okay, that's why the LEDs are turning on in such sequence. Now we will move towards the handout 2 code. This is the handout task 2 codes. Now we have two activities. Let me open their Proteus first, and I will open their Atmel too. Just close this one. And I will open their Atmel code first. So because it takes some time to get open, and now I will move towards their Proteus. So this is the Proteus for the activity one, in which we have to display the 7 segment. I'm opening the Atmel code right now. Now as you can see, this is the Atmel code, okay, which I've explained earlier. I thought that it was the handout 1 task 1 code, but I explained you the handout 2 task 1 code. Now I will just open the task 2 code of handout 2 too, so I will just explain you that. So the task 2 of our handout 2 was to interface an hex keypad and glow any LED okay, and I have to display that if whenever we press any button on the hex keypad, the LED turn on. So first of all, similarly, I'm just including the libraries, and this is used to, you can say this is the like used to communicate with our AVR, like that I'm usually setting their frequency. Now first of all, I have set the DDR pin 3, 4, 5, 6, 7 as an high, and then on the DDRC I have declared pin C as an high. Okay, so these are the output ports, like pin 3 of the port D, pin 4 of the port D, pin 5, pin 6, pin 7 of the port D are output ports, and pin 0 of the port C are output port. Now what I am doing in this code is actually checking that if bit set, like if I press any key on the hex keypad, its bit will be 1. So I am just checking that if our pin D of the port, pin 4 of the port E gets high, or the pin 5 or the pin 6 or the pin 7 of the port E, then turn on the LED, otherwise turn off the LED. So that it was the code. Now first I will just simulate the first simulation of 7 segment display. So wait a minute, this is the wrong simulation. I will just open the right one. Microlab simulation. So over here, as you can see, as I will run it, so you can see over here it is running over there up to the B. That was our 7 segment. And now I will move towards our task 2 simulation, which is to check if our hex keypad, if we press any button on the hex keypad, the LED is closed or not. So Proteus is taking a while. It will just open. So now it's open. Over here, as you can see, I have interface and a hex keypad with 80 mega 328p, and over here is the LED. So if I will press any button on the hex keypad, the LED will turn on. Look, if I press 7, it gets turned on. If I press 8, it gets turned on. If I press 4, it is getting turned on. If I press 0, it gets turned on too, because I have given the 5 voltage. So I have set the columns high, and I am taking input from the rows. So to interface that hex keypad, there is a way, either you give high to the rows, or you give takes input from the column, or you give high on the columns and take input from the rows. So that's it for the labs 1 or labs 2 and labs 3. I will just